Okay, we're going to go ahead and complete our section on linear equations, especially pertaining to the story problems. And remember, we're working with a new equation here, which is called the point-slope form. In other words, we need a point and a slope. Well, let's take a look. We have a couple points that I think we can come up with this from this problem. We're going to take those 2 points, find the slope, use one of the points and the slope to draw the graph, and then answer some questions further on down the road. Let's go ahead and read. The number of times a cricket chirps per minute depends on the temperature. The number of chirps is in 2 seconds for 2 temperatures are shown at the bottom right. So 40 degrees, there were no chirps over a 2-second period, and when it was 93 degrees, there were 8 chirps over a 2-second period. So if we want to think about this in the form of coordinates, we first have to think about independent and dependent variables. Remember, independent, technical difficulties, sorry about that. Independent here, and dependent. Independent is just that. It's something that is independent of the other variable. Dependent is just that. It is dependent on the other variable. Well, let's think about independent and dependent in this situation. A temperature of how warm or cold it is not dependent on crickets. That would be weird if the more crickets chirped, the warmer or cooler it would get. That's a bizarre little world to live in. So let's think about it the other way. Perhaps the temperature dictates how often crickets chirp. That seems to be a lot more reasonable. So the chirps are going to be dependent upon the temperature. And if you recall from your textbook, independent goes here on the x-axis, and y is for the dependent variable. So we're going to have temperature down here, and then chirps here. Let's keep going. So if we have x being temperatures and chirps being the y variable, when we have coordinates, remember x comes first, y comes second, x is going to be the temperature, y the number of chirps. First idea we have is that there was 40 degrees and there were 0 chirps. Next idea we had up here was that it was 93 degrees and we had 8 chirps. These are our 2 points. Now we're going to go ahead and find the slope. Well, if you recall, slope is the subtraction of the y's over the subtraction of the x's. So 8 minus 0 over 93 minus 40. So that's going to simplify to 8 over, let's see, that's going to be 53. Okay, so now that we have our slope here, I first want to go ahead and plot some of these coordinates. 40 degrees, 0 chirps, 93 degrees, 8 chirps. But I've got to be careful here because these chirps are in seconds. And the problem, remember, is asking you for uh, the number of chirps per minute. So if there's 60 seconds in a minute, I'm probably going to multiply these number of chirps by 60. Sorry about that, not 60, 30, because these are in 2-second format. So I'm going to multiply this by 30 and then this by 30. So really my coordinates are going to be 40, 30 times 0 is going to be 0. and 8 times 30 is going to be 240. So what we're going to have to do is create our scale over here for chirps and for temperatures. We've got it here for temperatures, did it by tens, but the chirps are going to be a little bit different because one of our highest chirps is going to be 240. So we've got 10 spaces here. So if 240 is going to be our highest, maybe call this 250 or 300. Let's use 300 here. So that's going to be 30, 60, 90, and so on. Now let's go ahead and plot these coordinates. We have a temperature of 40 and 0, and 93 degrees and 240. So we're going to call that 93 degrees. That's going to be right there at 240. So that's going to be our line. So now let's talk more about the equation. We have 2 points. Now let's go ahead and use the slope and these 2 points to find an equation. How about using point slope? Of course. X1 is going to be here. So then let's just fill in the blanks. Y minus my Y value. What point do you want to use? I don't know. Let's use 40 and 0. So 0 is my Y value. And my slope is 8/53. And my X value is 40. And there is my equation of this graph. That's one equation. Now, we could probably clean this up and have y equals, since that's 0, 8/53 times x minus 40. And if we wanted to put it into slope-intercept form, we could just multiply 8/53 all the way through. But they just need an equation of the line for this function, and also to do a little bit of changing around here. So let's go from this point-slope form to a standard form, which remember is ax plus by equaling c. So what we're going to do is actually do that distribution. So let's go ahead and distribute 8/53 here. Four times 8 is 32, add a 0. Now it seems if we multiply everything by 53, we'll get rid of these fractions. And it seems if I subtract 8 from both sides, I will have a standard form. And there's our standard form of the equation. So let's suppose we wanted to find out and use this function, remember this is a function, to determine how many cricket chirps to expect in a 1 minute time frame. Well, our function here is y equals 8/53 x minus 320/53. We can plug it in here, or we could plug it into our standard form. I think it might be easy if we plug it into the standard form. That way we'll avoid these fractions. So let's do that. -8 times 70 degrees Okay, sorry about that little mishap right there, but let's plug these back in here. Like we said, plug in 70 degrees into the function, and let's see what that simplifies to. 8 times 7 is 54, add a 0. And that's going to leave us with -320 on this side. Add 540 to both sides. Sorry, that should be 560. I still feel like it's a Monday. And then combine these two, so that's going to be 240. Divide by 53. And a little bit of handy dandy calculator work is going to get you to about 4.53. Now, let's take a look at our graph, 4.53. That doesn't seem to make sense because we're thinking if we go to 75 degrees, then it's going to be somewhere, I don't know, about right in this area right here. So I don't think 4.5 is going to be our answer. However, let's take a look at what we did. We had 4.53. Remember, that's the number of chirps originally we're going to have in 2 seconds. So to find out per minute, we're going to have to multiply that times 30. And then when you do multiply that times 30, you have about 135 chirps. And if you go to the graph, 135 chirps is going to be about right somewhere between here and here, because that's where the 75 is. So if you went to 75 and 135, your value is going to be right here. So pretty darn good guess with this linear function of the number of chirps per temperature. Next time when we check in, we're going to be working with parallel lines and perpendicular lines, and then how to convert all these lines back into standard form, convert all these lines back into slope-intercept form, and be able to graph, in essence, anything we would need to with linear functions. See you next time.